Hey there, everybody. Welcome to the next quarantine note. This will be number 4 in the series. And today we're going to talk a little bit about words versus pictures and images and inking. If you've not seen how we're doing this or why we're doing this, please go back and take a look at the very first one. It talks about my history of giving so many keynotes over the course of the last 20 years and workshops and trainings. This is one of those bits. I hope you enjoy. To start, I just want to admit something to you that I would guess many of you can also suggest to me. I love words. I am a communications degree holder. I have my master's in communications before I got my doctorate in education. I like rhetoric. I like semantics. I really, really love words. In fact, if you look at the surveys of people who love words, there are generally just a couple of categories of those people. Pastors love words, preachers love words, professors love words, publishers love words. But outside of those areas, not a lot of other people really like words, not nearly as much as we do. So while I definitely consider myself a wordsmith, it's important to know our audience. And our audience is pretty clear. Most people don't like to read too much. Most people don't like to be talked at too much. They would rather consume with their eyes and their senses rather than just with their ears or reading text. Yet, most professors that I know still create copious slides full of text. Either we get them from the publisher and we just use them, or we build out these really lengthy wordsmithed slides. We spend hours sometimes crafting these slides, and occasionally we'll get a really nice image to go with it, but it's really just sort of to support the slide rather than the other way around. And then we spend a lot of time talking. We tell and we tell and we tell and we tell. We read the slides that we've created to our students, suggesting that they're so stupid that they can't read them themselves, or we don't use slides at all. We just talk to them. We just expect everything that we say to kind of fall out of our mouths and be written down word for word, which, you know, if you read almost any of the literature, but I'll go back to Make It Stick by Brown, that's one of the worst possible ways that you can possibly go through an educational experience, is by taking copious notes, then going back later and trying to highlight so that you can remember. It may result in some short-term memory. It will not result in long-term learning, almost ever. So when we think about words, I think it's important that we look at some science around words. And I like to go to Medina. John Medina wrote Brain Rules. He has done these sorts of experiments over and over and over again, copious times in his career, where he brings people into his laboratories. He lets them hear words, or he shows them words. And he shows them words in list form, in narrative form. And then after they hear the words or they see the words, he brings them back to the lab several days later, 3 days later, and he asks them how many they can remember. They have an oral quiz. Well, they can usually remember about 10%. He then lets them go. He brings them back to his lab about 3 months later, and he asks them again how many they can remember. They usually remember about 3% of those words. Now, sometimes they've been able to study them, sometimes they've not. There's all sorts of conditions, but generally speaking, that's the retention rate of words. At the same time, he will bring people into his lab and he will show them images. Up to 2,500 images at one sitting. Sometimes he only lets them see the images for 10 seconds at a shot. And yet, when he brings them back 3 days later, how many do they remember? 90%. They can recall the elements of 90% of those pictures. When he brings them back 3 months later, they remember 63% of those images, almost 2/3. It is quite remarkable. Pictures trump words in the human brain. Now, please hear me. This is not a matter of visual learner or kinesthetic learner. This has nothing to do with learning style and all of that stuff. This is scientifically proven that the human brain can remember pictures way, way better than it can words. If you'd like to see, I actually can show you. Let me give you a test. Now, I'm going to ask that you don't cheat on this test. I mean, you'd just be cheating yourself at this point, so why do that? Don't take a picture of this. Just use your brain and try to remember these words. You're only going to see them for a few seconds, and then I'll ask you in just a couple minutes how many of them you can remember, okay? So you'll see them all come down as a list one at a time. See how many of these you can remember. and stop. Very good. Now, what I've just given you is what scientists would call a declarative list of information. It is explicit. They are facts, very similar to events. They are what they are. The word is the word. And I asked you to remember that. Now, I happen to know that if I would have asked you to remember those words by also giving you some non-declarative information, senses or responses that are emotional in nature or some sort of movement. If I would have done those things, I know you would have remembered the entire list much, much better. See, we know that when people start to take those concepts and apply them in an augmented way, in a kinesthetic way, in a way where they actually can use other elements of their brain, that they remember better. But again, I chose not to do that. I chose to give you the information very much like most lecturers give information to their audiences of students, which is they just say it or they have them read it or they read it to them. See, what that process is called that we're trying to really utilize here is called visual indexing. Visual indexing is something we've known about for decades. It's the term that we're really trying to get you to index the things that you're seeing and then put them into your long-term memory in the hippocampus. We're trying to get you to put that stuff into a place where you can recall it and really use it. I can actually mess with your visual indexing if I want to. Let's try this other experiment very quickly. Now, I'm hoping you're alone. If not, close your door. See if you can do this. I'm going to ask you to read another list. This one, you don't have to memorize. You just have to read it out loud. But the key, as you're reading it out loud, is you read it from top to bottom as fast as you possibly can, out loud. I want you to read the color and not the word, okay? As fast as you can, top to bottom, go. Did you have to stop? Did it cause a little bit of juxtaposition? Did you actually screw up early on? When I do this with audiences around the globe, it usually only takes until the third word, sometimes the second word, before somebody messes up and they read the word, not the color. Now, why would this be? Well, this is the Stroop test for my psychology teachers out there. You know this test. But essentially what's happening is this. I'm asking you to take two pieces of declarative information that you learned, cognitively speaking, a long, long time ago, almost at the same time. You learned the symbols for letters about the same time you learned the symbols for color. And I'm asking you to pull one piece of declarative information out over another piece of declarative information, which is very difficult for the brain to do. In fact, if you can do this readily, there's probably something wrong. So we know about visual indexing. See, when we get you to utilize more parts of your brain, meaning we've given you declarative information and non-declarative at the same time, when you have moved, when you have had some emotional responses, look at all the different parts of the brain you're now using. Suddenly you're tapping into not just the temporal lobe, but you're actually using the cerebellum, you're using the neocortex, you're using the amygdala. Other parts of the brain are getting involved. And doesn't it make sense that when you use more parts of the brain, you're going to remember better? See, essentially at the end of the day, we're trying to train neurons. We can actually watch neurons today because of fMRI technology. We can watch them be born, we can watch them grow, and we can also watch them die. This is what we're trying to accomplish. The neuron that you see on the left side of your screen, that's a trained neuron. That is a neuron that was fed in more than one fashion. It's a piece of information that was then supplanted by other means available to it. The one on the right, well, that's a piece of information that was given one time in one way. It was just words. And that one on the right has very few neurites coming off that are looking for other neurites to connect to form a neural pathway. It is a neuron waiting to die. We don't want our neurons to die. We want them to flourish. Let's see how you did. I asked you a few minutes ago to remember a few words. I just want you to ask yourself if you agree with my sentence, yes or no, all right? Was the word candy in the list? If you say yes, go ahead and just say it out loud. Good. Was the word car on the list? If you say yes, go ahead and say it out loud. I usually don't fool people with that. Was the word sweet on the list? If you say yes, go ahead and say it out loud. Did you say sweet? About 90% of people in audiences do. And you know why? Because they're adding non-declarative feelings to a declarative list. I showed you a list of sweet things. I didn't show you the word sweet. You added sweet on your own. See, that's what the human brain does. We add context, we add color, we add things that aren't there just to sort of fill in the blanks. You know what happens every time you send home a reading, by the way? Your students do this. Every time you're talking out loud, your students are doing this if they're paying attention at all, which there's a lot of studies that show that they're probably not. So as we start thinking about words and words and words and words, let's start moving into a realm of some things that we can use. I think about note taking. How many of us were taught how to take notes? I know I never was. As I've delivered these messages around the globe, most people say they were never taught how to take notes. It was just assumed that you were told write everything down. And so people try to write everything down, which we now know is a horrible way of taking notes, but that's what people do. Instead, why don't we use a methodology developed by Dr. Stephen Carroll up in Minnesota, a neuroscientist who talks about how to kind of use the way that our brains work sort of to their best. You want to start with some metadata. So let me actually draw a little bit on here. We want to make sure that we've got some metadata so we can find it easily. This is, by the way, why it makes it so great to use Evernote, OneNote. Digital means where you can actually look up the metadata rather than having to thumb through a notebook. But if you like paper, that's okay. Next, we want to write down in as few words as possible the connections, the information, what it is that we're actually learning. You might notice that you've got a question and maybe right underneath that you write the answer or something like that. Something short and small, abbreviated to the point. Now the next part, well, here's where some of the magic starts to happen. Now is where we get into images. Try to draw what that means to you. Try to draw meaning. Try to draw synthesis, analysis. Now, you don't have to be a great artist. Usually when I say this to people, this is the step where they go, oh, I can't draw. I'm not an artist. I'm not either. But I have started using this methodology and it really makes a difference because these drawings, these doodles, they mean something to me. Now, when you're done with that, when the learning experience is over, go ahead and write a couple of big ahas. Why is this worth remembering? What's the most important thing here? And then if you really want to get bang for your buck, review it before you go to bed that night. If you review it just before you go to bed, amazing things will happen with your memory. You'll remember about 11% more than if you just let it go. We have used this exact concept and philosophy in trying to teach our daughter as she goes through and generates her notes in school all through her career, and she can remember an amazing amount of things after she simply goes through this process. What we're really trying to deal with is we're trying to help with cognitive load. See, when it comes to cognitive load, we want to focus on just what matters, the germane, what is really important here. Unfortunately, that doesn't happen very often in higher ed especially, because a lot of times we're teaching classes that we're bored with because we know this stuff. We've known this stuff for years. And we forget that we've got learners who don't necessarily know this stuff as well as we do. And so what do? Well, rather than maximizing the germane, we often will maximize the extraneous or sometimes the intrinsic. We'll talk about things that we think are interesting or kind of cool because it helps keep us engaged and involved, forgetting all the while that our students only need the germane. They only need to know what matters. And so we get bloat and more bloat and more bloat and more bloat over time. And now we're expecting them to remember far, far, far more than they have to remember. Or as we're trying to present the information, we forget all this altogether and just go right after saying, hey, here's the important stuff that matters. Let's say we're trying to teach the heart. And so we get a nice, great high fidelity picture, a picture that requires a tremendous amount of information, and what you could probably see already is information overload. And we say, this is the heart. Well, what are the problems here? Man, way, way, way too many things to consider if you're just now learning the heart. At the same time, the picture itself, it's perfect. It's absolutely perfect. There's very little need for my brain to try to understand how this actually works in some sort of meaningful way. It washes over my brain like a television show. That's how it works. So I've got droning going on with a lot of words. I've got pictures that are really way too complex for me. And instead, I just treat the whole experience like a TV show, and I forget almost all of it. Instead, here's what we did when I was at St. Leo. We developed a tool that was called Metal. It was a whiteboarding system. And we brought students in and we said to students, I'm not going to draw something for you. I'm not going to show you a picture of a heart. Instead, I want you to draw a heart. You know, some students said, well, wait a minute, I don't know how to draw a heart. I've never done that before. And you say, okay, that's all right. Just give it a shot. And so students could do this. They could do it together. They could do it with, you know, by themselves, whatever. You could do this right now using Zoom and the whiteboard in Zoom. As we're going, if I'm talking too quickly about it, I could actually have somebody go, whoa, slow down. Let's take it easy. But as they start to draw, I can now come alongside them and I can say, okay, wait a minute. I've got a very important question. First of all, I think you've mixed up your atriums, but besides that, why did you draw this heart symmetrically? A heart pushes on one side and pulls on another side. What does that tell you about a muscle? And most students say, oh, well, sure. If it's going to push on one side and just kind of have stuff flow into it on the other, then one side's probably going to have to be bigger than the other. Ah, yes, it needs to be asymmetrical. And now we can start to have some meaningful conversations. I do this with my students all the time. In my education classes, in my communication classes, I have them draw continuums. I talk about drawing things like the arc plot so that we can actually see that they know how to tell a narrative or tell a story. We actually talk about the different Venn diagrams that go along with brain science and what actually sits here in the middle. I have them draw things all the time because it helps them to learn. I would encourage you to do the same thing. Thanks for your time. I hope you start to use some of these tools to train your students a little bit differently so that they're actually remembering the information. Have a good day, stay safe, and try not to catch that ugly corona, shall you? Bye-bye.